personally, I think that this is too high of a degree of difficulty for you. I don't think it makes sense for us to spend this hour working on super difficult problems like that one, remember? It's not that you don't have to know this stuff, you do, but it turns out that pretty much every problem that we went over had like 4 sub-problems that you had to know how to do each thing. And then to get the right answer, of course, you needed to be virtually perfect. I'm inclined to think that we'd be better off doing easy and medium problems.
Yeah, for sure. It would be good if we did the geometry ones. I think that's what gave me the most trouble.
Let's do the geometry ones. Now, what happened here is somebody cut and pasted a bunch of geometry problems from tests and kind of put them together, I think. Yeah, these aren't numbered sequentially. In a circle of radius 6, what's the measure of an arc whose length is 2 pi? When you're dealing with circles, when they give you the radius, you can calculate the circumference and the area.
Mm-hmm.
When they talk about arc length, that's similar to circumference. Okay, so let's figure out what the circumference of this circle is. What's the general formula for circumference?
2 pi r.
So for this circle, then, it's 12 pi. Okay. So if they ask you what is the arc length of the circumference, it's 12 pi. Okay?
Okay.
Which means that an arc length of 2 pi must be what part of the circumference?
1/6 of it.
Okay, so it's 1/6 of the circumference, which means it's like that. What degree measurement is that? What is 1/6 of a circle in terms of this angle?
60 degrees.
You got it. In other words, 2 steps here. You need to figure out the circumference and then figure out what part of that circle they're talking about.
Mm-hmm.
I'm gonna skip this. Some of these, notice it goes 2353. I'm not convinced that some of these you need to know. I've never seen this question here on a practice test.
Okay.
It's one of those oddball geometry questions. I take that back. Let's do it.
Okay.
I take that back. I have seen this. This is not what I was thinking it was. And there actually is a very important concept that's illustrated here. CD is 8. What's the measurement of each of these 2 segments? Because this radius is perpendicular to this chord, it bisects CD.
Okay.
So if CD is 8, what's the measurement of each one?
4.
Okay. And the other piece of information is OE, Here's the center of the circle, O. Here's E, that thing. That is 3. What is the length of the radius of the circle?
Is it 5?
Very good. Right there, that's a 3, 4, 5 triangle. Definitely want to learn to recognize those. So I guess the only difficulty here was knowing that if a diameter of a circle intersects a chord at a right angle, that it bisects that chord.
Okay.
Okay. Now this is the one I wasn't sure I had ever seen. Let's go over the concept real quickly. If you have a central angle that is theta, that is also theta.
Okay.
In other words, if that's 30 degrees, that arc length is 30 degrees. If you come from the edge of the circle like that, then this angle is 1/2 theta, meaning the arc length is twice what the angle is. And that's kind of what they're asking here, is they don't tell us what the angle is, but they tell us what is the relationship between ACB and AOB. They both intercept the same arc length. In other words, that's exactly the way I've drawn it here. Well, how would you figure out the ratio of ACB to AOB?
Isn't it 2 to 1?
Make sure you get it in the right order. This is ACB, and that's AOB.
Okay, so 1 to 2. That makes sense.
Yeah, in other words, it's 1/2 theta versus 1 theta. And the thetas cancel, and you end up with 1/2 to 1, which is 1 to 2. Or actually, the way they've written it, 1 to 2.
Okay.
C, not B.
Okay, that makes sense.
Okay, let's see. I think I have problems on this side also, yes. Apologize for these aren't that easy to read.
No, that's okay.
Partly it was because it was from either a student's parent or a teacher. I think a teacher actually did this. She copied and pasted some. Okay, this is again, this feels like that area of geometry where you take it in geometry class, but then you're never quizzed on it again. And there's a lot in geometry class that's like that.
Right.
I would say 2/3 of geometry, you're never going to be quizzed on it again, like proofs and stuff. They're saying the measure of that is 40 degrees. And they want to know what angle COB is.
Okay.
Take a look at the answers real quick. Take a look at that angle.
Okay.
What's the right answer?
B, 80.
COB.
Oh, COB 140 because it's bigger than 90 and none of the rest are.
Clearly it's bigger than 90.
Yeah.
By a lot. Now, you can't always go by how the picture looks because they don't always draw it to scale, but this isn't even close. But let's go through the analysis. If that arc is 40 degrees, what's this angle here?
40.
Correct. If that angle is 40, what is the angle that it is a linear pair with? In other words, that angle right there.
140.
And that's how you come up with it.
Right.
But it does go to show you that, well, even if you don't have a clue, you're getting this one right if you just look at the picture.
Right.
I mean, if you don't have any other way of solving it, that certainly is the best way to do it.
Yeah, for sure.
If you can, rather than making a pure guess, look at the picture and make an educated guess.
Okay, that makes sense.
All right, again, let's skip this one. This is the same principles we've already had, and this is the principle that I didn't think I had ever seen on a test. I still don't. And along with this principle, I've never seen this on a test. Let's not waste our time. I got other tests.
Okay.
Can't see what's above it, but 50. What is the area of the shaded region? What's the first thing you should think of when you get an area of a shaded region question? What kind of problem is
it? Geometry.
A subtraction problem, always. In other words, we don't have the math. We've never been taught the math to figure out that area, that region, or this region. But what we do know how to figure out is the area of the square, and we know the area of the circle. So by subtracting the circle from the square, we would get the area of all 4 corner pieces. So how am I going to do this?
Wouldn't you have to find the area of the square is 36 if it's a square.
And it is. It says a circle inscribed in a square.
Okay. And then
what's the area of the circle?
Yeah, do the area of the circle, and then
what is it? What's the area of the circle?
So it's the radius pi r squared, so it's 9 pi.
So minus the area of the circle.
So
that answer would give us, if that was black or gray and that was shaded, that's what the answer would be. What do we have to do to get the right answer? In other words, how does this problem differ than if all 4 corners were shaded?
Oh, you divide it by 2.
Yes. Which answer is that?
F.
Okay, good. You actually are doing pretty good in these geometry problems.
Yeah, I was always fairly good at geometry. It's just I don't know, connecting the dots again because I haven't taken it in a really long time. But I got an A in geometry.
Yeah, no, straightforward one here. If the diameter of a circle is 8, what is its circumference?
What is its circumference? So, 16 pi.
It's 2 pi r.
Oh, circumference, not area. 2 pi r. So, 8 pi?
Correct. You're correct. 16 pi would have been the area.
Mm-hmm.
Just remember those two things have the same numbers. Area is pi r squared. Circumference is 2 pi r. It's So in other words, all you really do is bring the 2 down in front. It's kind of like taking the first derivative.
Okay.
The area of a sphere varies directly as the square of its radius. Let's talk about varying directly and varying inversely.
Okay.
If I say y varies directly with x, how do I write that?
I'm actually not sure how you'd write that.
Okay. It means y equals some constant times x. And this is direct. Okay? And what that means is that if x goes up, y goes up. If x goes down, y goes down. The other kind of varying is inverse.
Okay.
It's y is a constant divided by x. In an inverse varying, if x goes up, y goes down. And if x goes down, y goes up. So they're definitely different. And these are the general formulas. Every situation has a different k. And so a typical question will say, y varies directly with x, and when y is 10, x is 5, and the next step is always to figure out what k is. Well, if I plug in y of 10 and x of 5, I come up with k equal 2. So the equation for this particular model would be y equal 2x.
Okay.
Okay? Same thing for this. It's all about figuring out what k is. And they have to give you 2 pieces of information that are going to allow you to figure it out. Okay, so let's translate this into what they're saying. The area of a sphere varies directly as the square of its radius. See how I wrote it?
Yeah.
Okay, and they're going to tell us an area is 36 pi when the radius is 3. So that's going to allow us to figure out k. So 36 pi equals k times 3 squared. So k equals 4 pi, which means the equation for this thing is area equals 4 pi r squared.
Okay.
Okay? And they want to know what the area is going to be when the radius is 6. In other words, they gave us the 2 figures we needed to solve for k. Now we know what the formula is for this model. And they want to know what is the area when the radius is 6.
Okay.
What is it?
When the radius is 36 times 4, 144 pi.
Uh-huh. My 3rd page. This is funny. I was working with another kid who didn't do online. He only did in person. And we were preparing for the ACT, and I couldn't get him this. My printer was broken. I could not get this document that had all these good geometry problems on it to him. So it was one of the few times where I could do something online that I wasn't able to do in person. You know what I mean?
Yeah, for sure.
The diagonals of a parallelogram intersect at point E. Well, let's just draw a parallelogram. And the diagonals intersect at E. And that's A, B, C, D. If DB is 4x plus 2 and DE is x plus 4, solve for x. What do we know happens at the intersection?
It splits it in half.
Correct. So now tell me the equation that will help me solve this.
Would it be 4x plus 2 equals 2 parenthesis x plus 4?
Yes.
Okay.
Now solve that.
That is...
What's the first step? Just read each line to me.
So 4x plus 2 equals 2x plus 8.
Now what?
2 equals 2... Oh, wait, just kidding. 4x equals 2x minus plus 6. And then 2x equals 6, and then x equals 3.
Okay, cool. Might as well practice our algebra while we're doing this. Okay. This is an isosceles trapezoid. That means much like an isosceles triangle, the two sides are equal. Okay?
Okay.
Now, finding the area of the isosceles of any trapezoid, we need the vertical height. Okay? So we need to figure out, we know the two bases, but we need to know this height right here. We know that's 26, and that's 50. What's this distance?
So is it
What's this distance right there?
10?
So what kind of triangle is that? What's the height?
The height is...
That is one of your perfect Pythagorean triangles. That's the second one.
Is it 8?
No. In other words, you have 3, 4, 5. And you also have 5, 12, 13.
Oh, yeah.
That's the second lowest one. And you get a mixture of both of these quite a bit on the test. I would say you get more of these than you get triangles where they force you to use the Pythagorean theorem to solve them.
Okay.
And notice that this triangle, everything is double this one over here. So what is this measurement?
That one is 12. Oh my goodness, 24.
Now, how are we going to get the area of that trapezoid? There's two ways to do it. There is 1/2 the average base, which is base 1 plus base 2, divided by 2. That's the average base, times the height. Okay? We have everything. We have the bottom base is 70, the top base is 50, and we know the height is 24.
Mm-hmm.
So the area, fill in everything for me here.
So 1/2 parenthesis 50 plus 70 24.
What's that answer really quick?
I
mean, there's a quick way to do it without a calculator. Notice the 2 goes into the 24 12 times. Now you're multiplying 12 times 12. We know what that is. It's 144.
And then add a 0.
So it has to be D, yeah. Okay. Yeah, hold on. Oh, I guess I'm done with this page. Now, hold on. If the perimeter of a square is 3x, then in terms of x, what is its area?
Wouldn't it be, it's 3 divided by 4, so 3/4 and then squared. 3/4 x squared.
That's not on there. You might be on the right path. In other words, that's not the exact way to do it. But what answer looks like it might be that?
9.
No, C. Notice that 9 is 3 squared, 16 is 4. So if you started with 3/4 x and squared it, you'd have this.
Right.
Okay. Here, let's do it the right way. S is the side length of the square. They've told me that 4s, the perimeter, is equal to 3x. Right? So I can solve for s. S is 3/4 x. And what's the area of the square? The area is s squared, or in our case, 3/4 x squared. And that does give you answer C.
Okay.
All right, again, just so I can explain it, let me draw their picture. So one thing that's different about online and in person is if we were in person, I'd probably be writing on this book.
Right.
That's what I used to do all the time, which is not good. But okay, if x, not shown, is the midpoint of CD, well, there's the midpoint of CD. Okay, so there's x. And y, not shown, is the midpoint of AD. Well, there's the midpoint of AD. We're going to call that y. What is the perimeter of XYD, that triangle?
12.
So this is 3, that's 4, and that's 5, again with the 3, 4, 5 triangle. Boy, they don't even make you use the Pythagorean theorem even once, hardly, huh?
No, looks like it.
Well, from what most practice tests I've seen, yeah, out of 10 right triangle problems, 8 or 9 of them are going to be either a 3, 4, 5 or multiple, or a 5, 12, 13. So if you you know what those are. You know what a rhombus is?
Yes, kind of. It's like a diamond-looking thing, but it's not.
4 equal sides.
Okay.
That's the definition of a rhombus. Okay, it doesn't have to be that. In other words, a square is a rhombus. But a rhombus doesn't need right angles. In other words, these don't have to be right angles.
Okay.
It's just that 4 equal sides. Okay? And what they're doing is telling us that one side is 4x minus 2, and another side is 3x plus 3. Solve for x.
X is...
Definition of a rhombus.
Is it 5?
Uh-huh. Let's see. Let me go up to the top of this. Ooh, this is a tricky one. I'm not sure if this isn't another one of those geometry things that you don't really have to know. But maybe. If the sum of the measures of the interior angles of a polygon equals the sum of the measures of the exterior angles, how many sides does it have? Well, to answer that, what's the sum of the measures of the interior angles?
180.
About the exterior ones?
Still 360?
Uh-huh. Same for a square. The interior is 360, the exterior are 360.
Okay.
Okay? So no matter how many sides a polygon has, the sum of the exterior is always 360. Even notice if I draw a hexagon, notice that the exteriors, these are all acute angles. So the more sides it has, the smaller these exterior angles get. And that's why they always total 360, no matter how many sides it has. So what's the answer to the question?
3.
No.
4. 4, 4.
4. Because with 3, the interior would be 180.
Right.
The exterior is still 360.
Right.
Go ahead and do that. You have a calculator in front of you?
Yeah.
This is one of the few questions where a calculator really will facilitate it.
All right, 65, G.
Come on, I didn't get that. What did I get? I got 202, 295, 360. Yeah, sorry.
That's okay.
That's where I needed a calculator. Oh, it's like the Big Dipper.
Yeah, it does.
I've been seeing that pattern everywhere lately. The area of the square is represented by K. What is the perimeter of this square in terms of K? Let's do the same kind of analysis that we did before. What should I let this side be?
K.
No, area is represented by K. I can't let a side be K. What is that side, though? If the area is K, what is each side?
The square root of K.
Yep. Now what's the perimeter?
The square root of K times 4.
Yep. Let's see. 4 square roots of K.
Sweet.
Yeah. All right. That's all. We went through those 4 tests pretty fast. Let me go to... You're taking it for the last time Saturday?
Hopefully, yeah. I'm trying to get a good enough score that I don't have to take it again.
Okay. Trying to see whether or not I need to pay attention to whether... I don't want to run out of questions, but I got lots of tests. I got like 8 tests in my computer. I just want to make sure I know which ones we've done and which ones we haven't done.
Right.
In fact, if you recognize some of these, we may have done this one. I don't think so, though. I started on test 3 randomly.
Yeah, I don't think we've done this one.
Okay. Go ahead and read these to yourself, not out loud, and then start putting speed in your mind. In other words, I want you to start thinking of, okay, I need to answer this as quickly as possible. One thing we have never done is incorporated speed into our process. But if you're going to take the test this Saturday, you need to start thinking about speed.
Yeah, of course.
Okay. So what's the answer?
D.
B says W is less than 1,500. Did you say D as in David?
Yeah.
Yeah, that's it. In other words, it can be 1,500.
Right.
At most, it can be 1,500.
Mm-hmm.
It's the smallest positive integer that is a multiple of 2, of 6, and of 9.
H18.
Which of the numbers cannot be 0?
U. Only A.
What percentage of residents do not have a White House? What's the easiest way to do this problem?
Probably find the percentage that have a White House and then subtract from 100.
Yes, which is going to be easier than subtracting 648 from 2160 and then dividing that by 2160. So
70% H.
Okay, so that's 30% of that?
Yeah.
Okay. Go ahead and, boy, these are awfully easy, especially compared to the ones you had in your practice test and the ones, my geometry problems even.
Yeah.
Okay, there's nothing wrong with boosting your morale. Actually, this whole session tonight should have boosted your morale. You've done pretty good.
Oh, thank you. I got D.
Good. Go to the next page. Can you see that, or let me blow it up
No, I can see it.
a little bit. Okay.
Is it F?
Uh-huh. There's a lot of questions on parallel lines, if you remember, and transversals. So
okay.
These are important. We want to make sure you understand parallel lines and transversals.
Okay.
You don't need to know that these are called alternate interior angles. You only need to know that they're what?
Complementary.
They're equal.
Oh, well, yeah.
M is equal to N. Just like, let's go over parallel line. When you have two parallel lines and a transversal, you create 8 angles. I'm going to number them. But you only create 2 unique angles. And that's 1 and 2. Everything is either 1 or 2. In fact, the way you can look at it is you have an obtuse angle and you have an acute angle, and they are supplementary. And every obtuse angle is the same size as 1. Every acute angle is the same size as 2.
Okay.
So in our picture, do you see why M is equal to N?
Yeah.
Okay. Now, the only time they could potentially really try to confuse you is if they draw something approximately a perpendicular line. And now it's not so easy to see the acutes and the obtuses. But I don't see any questions like that. They're always, the transversal is always slanted. Okay? So,
okay.
If M is equal to N, what is M?
M is 115.
What is O?
65.
Right. M and O are supplementary. Both because they're a linear pair and because adjacent angles are always supplementary when you have 2 parallel lines and a transversal.
Okay.
Now, you've read this, right? Let me stop you just in your tracks. Is this ever a problem you would check mark and come back to?
Maybe.
Look at it again. They're telling you what the volume is, and they're giving you H and R.
So no.
No, never. I mean, this is always a problem you're going to get right, as long as you don't make a math error. Okay? So the reason I stopped you and asked you is because, first of all, there's 5 sentences or 5 lines in this thing, and most people tend to operate on the assumption that the longer the words, the harder it is. Well, that's not true. The other thing is they give you a rather complicated formula. And they don't even give you this equation. They tell you the volume, a word, is equal to that.
Right.
But this is the easiest problem in the book. This is absolutely a level 1 easy grade problem, and you don't want to not do these. In other words, don't make the assumption that a problem is hard just because it might seem hard at first glance.
Okay.
What is the volume?
The volume is J80 pi. C3. One.
Yeah, no, you're on the right. You keep going.
Is it 110?
No, what's the measure, the total of the exterior angles? That's what we have here is 3 exterior angles. They always total 360.
Oh, so just add 135, so it's 115.
Correct. And you don't have to actually memorize that because what's this angle right there?
115.
No. These two are supplementary. That's 110. What's that?
80.
What's this? No, 70. What's this?
Oh, yeah. That one is 30, 45.
45. So we got 70 and 45, which means we can now figure out what that one is. This 65.
Okay.
And once you know that that one's 65, that's a linear pair with Q, so you would know Q is 115. But it's obviously much quicker to know the sum of the exterior angles is 360.
Right.
The only thing about that formula that I don't like is that when everything is crossing, how do we know that's not the exterior angle? Or that, or that. So it's not always 100% clear what the exterior angles are. But if you erase that piece and that piece and that piece, you would see that you're looking at 3 exterior angles. But there is a different way to do it, and that's to find the sum, or to find the interior angles.
Okay.
It's 11. Actually, I'm glad we went to this test because there's a lot of subjects besides geometry that you need to be able to.
Right.
Tell me what you're going to do here.
Boil it.
Okay. It's the first term. It's the F.
The first, so it'd be 2.
What's the second term?
Be -4 times the square root of 2.
The third term.
-6 times the square root of 2.
And the last term.
Is 24.
Plus 24.
Yeah.
Which answer is that? Combine all your like terms.
So 26 D.
Yeah, gosh, that's all you need to do, huh?
Mm-hmm.
You didn't even need to combine these two. Once you combine the 2 and the 24 and get 26, they give you breaks like that so that you get the first term and you're done.
Right.
Although it's not exactly hard to -4 root 2 minus 6 root 2 is -10 root 2.
Right.
That's relatively easy, but okay, what do you get when you square x minus 3y, the quantity?
X, huh?
Term by term.
Oh, parentheses. Don't we have to like split it up into foiling?
Yeah, that's what I was going to do. I just did feel the need to write it, but that's okay.
Okay. It's more helpful for me. X squared, and then -6 not too complicated. Negative 3yx. And then negative 3yx. And then plus 9y squared.
Which answer is that?
That's G.
Okay. And again, the only thing you might mistake is you might write one of them as xy and the other one as yx, but they're the same. Mm-hmm. They're still like terms.
Right.
That you can combine.
Yeah, for sure.
Okay.
A.
Yeah, I'm trying to figure out what the 5 is in there for.
I think it's just to confuse you.
X is an odd integer greater than 5, let's say 7. What's the next greater odd integer in terms of x?
It's plus 2.
Yeah. So it's x plus 2. Yeah. Strictly to confuse you.
Yeah.
So if it has the same graph, it must be the same equation, just rearranged.
Yeah.
Or, yeah. No.
Is it J?
Hold on a second. Well, yeah, it is J. In other words, it's not the same exact equation because that's a line, okay, first of all.
Uh-huh.
And we know that I can do anything I want to the left side of the equation as long as I do it to the right. It doesn't change the line. So J is, even though the numbers are all 3 times bigger, it's the same line.
Okay.
Okay. How we're going to do age problems, marble problems. There's a real simple way to do this.
That's B18.
How'd you do it?
I kind of just did, thought about it, like in my head. There's kind of like, I don't know.
Okay.
It was just kind of a thought. There was no formula or anything.
Well, let's back solve it. I don't think we want to try to set it up algebraically, but we do want to legitimately try to back solve it. Okay? So when you're back solving, especially in an age problem, you're always going to know whether your answer is too big or too little. Let's assume we start with D, 9.
Okay.
Here's the technique of back solving. Ann is equal to 9. Well, we know Ann is 3 times as old as Kyle, so what would that make Kyle?
3.
Their ages do not add to 24. Do we need a bigger number or a smaller number for the age of Ann?
Bigger.
And the very next one we're going to try is the second biggest. We're not going to try C, because we might still need a bigger, and then we would have to try them all. But notice by trying B, I'm going to have my answer. Either B is correct, or I'm going to know that I need bigger still, and I'll know the correct answer, or I'll know that I need a smaller number, and I'll know the correct answer. So when you start with either the second lowest or the second highest, you're virtually guaranteed of only having to do 2 back solves at most to come up with the answer.
Okay.
And just to show you how we would back solve with B, if Ann is 18, then Kyle is a third that, 6. Those add to 24. Bingo.
Yep.
That's kind of what you did in your head.
Yeah, I kind of did back solving in my head is what I was going to say.
Exactly. You just maybe didn't do it formally.
Yeah.
But I think it's important to do it formally because there are going to be some that you can't do in your head. And you're going to have to go through this kind of an analysis. And the very first step is to assume that your first pick is correct. And then go through the math and see if the whole thing makes sense or not. All right, Aspen, did good tonight. Take that. Hopefully that'll give you some good positive feelings for going into your test.
Thank you so much. Yeah, I feel really confident about it.
Good.
Yeah.
Good week and good luck.
Thank you so much.
Bye-bye.